Hello, my name is RD and we are going to solve problem 28. So the question is determine the terminal voltage of each battery in figure 2652. So there are two battery in this picture, but the drawing is not that obvious, but okay, let's highlight that. So this one here is a single battery with a internal resistance of 2 ohm. So this is a single battery. And then the other one is also a single battery here. So I will have a battery with the voltage of 12 volt with an internal resistance of 1 ohm. Okay, so this is also a single battery. So the question is determine the terminal voltage. What is the terminal voltage? So that is the voltage between this node here and this node here. So maybe let's name this node here as node A and then this node here as node B. So the question is asking us about VAB here, and then this node C and node D. And the second variables that we are going to find out is CD. So what are they? So this is the question asking us for. Okay, now let's label the current in this circuit. So maybe let's assume the current is going clockwise like this. So we will have this current loop here, and let's name this loop as I. And because only one loop is flowing here, so the current in the branch is also I, right? So I will have this current here is I, and then this current here is also I, and this current here is also I. So all over the loop, the current is I. Okay. Now, what can we do next is we label the polarity of each component. For battery, we have the long one here as a positive terminal, and then the short one here as negative terminal. Okay, and the same for this battery here. The long one is the positive terminal, and then the short one is the negative terminal. Okay, now let's label the polarity of the resistor. And let's see here, the current is flowing from here to here. So the positive side is where the current enters. And then the negative side is where the current goes out. So I'll have like this. And then this resistor also the same. The current is flowing from here to here. So the positive side is this one. And then the negative side is this one. And then one more resistor, we also have this positive part here, and then the negative side is here. Okay, so now we have labeled the loop voltage, the loop current, the branch current, and then the voltage of polarity of its components. So the next thing that we can do is we use Kirchhoff loop rule or Kirchhoff voltage law. Okay. So let's use that Kirchhoff loop rule or Kirchhoff voltage law. Okay, and or KVL, and KVL said that the sum of the voltage in a loop is equal to 0. Remember this, the sum of the voltage in a loop will equal to 0. But then we need to be very careful with the sign of the voltage here. Okay, maybe let's start from this 18 volt battery here. And let's see here, the current is flowing from negative terminal to positive terminal. So we will have negative sign. So I'll have minus. And the value is 18. So minus 18 here. And let's go clockwise here. Here we go from the positive sign to the negative sign. So I will have positive sign. and then I will have 5.8 ohm resistance. But remember that we need to get the voltage, and we can get the voltage by multiplying current with resistance, right? So we have resistance, so we can multiply it by the current. The only current that pass through this resistor is I. And then let's go another component here, and I will have this 12-volt battery, and the current is flowing from positive terminal to negative terminal, so we will have positive sign. So I will have plus 12. Okay, that is good from here. And then let's go again here. I will have this one here, which is goes from positive to negative. So I will have plus, and then I will have 1 ohm. So I will write 1.0. And this is resistance. To get voltage, we multiply it by the current, which is I. Okay, good. Now let's move on to this component here. I will have 2.0 ohm. So I will have plus 2.0. And this is resistance. Again, we need voltage, so we multiply it by the current. So I will have I here. And I think we got all the components, right? Let's count it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, we got all the 5 components. And all of that will equal to 0. Okay, now what can we do from here? Let's do some arithmetic, right? So I will have minus 18 plus 12. That will be minus 6. And then plus, I will have, what is it? 5.8 plus 1 is 6.8. 6.8 plus 2 is 8.8. So I will have 8.8 I. And then all of that will equal to 0. Or we can add both sides by 6. So I will have 8.8 I is equal to 6. And so I is 6 divided by 8.8, which is, let's do calculator from here. 6 divided by 8.8. Okay, we will have 0.682. Okay, 0.682. 0.682. And the unit here will be ampere. So this is one of the important value from here. But the question is not asking us about this current, but VAB and VCD. Okay, let's do exactly that. Okay, now let's see the voltage here. So we need to find out VAB. Okay, VAB. However, we have to be very careful here because VAB, the direction is from here to here. So we need to see the current of minus I, right? So let's do exactly that. So VAB is, remember, this current here is flowing from here to here. But then I will have 18 volt here. So it's going from positive to negative. So I will have 18. And then minus. Okay, now I will have minus. Why minus? Because the resistance here, I will have minus sign from here, right? And so I will have 2 ohm. Oh, however, when we dealing with minus I, this will be plus. So I will have plus 2 multiplied by minus this one here. So I will have minus 0.682. Okay, I think I just leave it into calculator. So VAB is 18. 18 plus 2 multiplied by minus 0.682. That will be 16.64. Okay, 16.636, and the unit here will be volt, right? And now let's do VCD here. So I will have VCD. and then I will have this one. So I need to get this one. So I will have 12. And then plus. Okay, I will have plus 1 multiplied by 0.682. Okay, so I will have, what is that? That will be 12 plus 0.682. I think I will have 12.0862. 12.682. And the unit here will be volt. So I will have VCD here is that value there. Okay, I think that's all for this problem. See you in the next video. Bye bye.